All right, so the next thing we have in this exponent unit is the combination exponent rules, okay? This simply means more than one rule at a time. Okay, so to quickly review the rules, okay, if I have two bases that are the same, okay, all the bases need to be the same, by the way, if you forgot, and they are being multiplied, I simply add the exponents, okay? Keep the base, add the exponents, so it turns into 2 plus 5, which will give me 4 to the 7th. Okay, that is rule 1. When multiplying the same base, add the exponents. Now, it gets a little tricky when there's negatives, which we'll talk about. Okay, but you'd still add if you wanted to. If it was a negative 5, you do 2 plus a negative 5, which is really just 2 minus 5, and so on. If you're dividing two bases that are the same, instead you will subtract the exponents. So this would turn into x to the 7 minus 4, which will give me x to the third. Okay, those are our first two basic rules, properties, whatever you want to call them. Okay, and the third one was when we have one base to a power to another power. So you notice I have 1, 5 here. It's one base, okay, to a power to another power. Obviously, you're not going to do the same thing as you did in the first ones. It's a different rule. Okay, it looks completely different, so that means you're going to do something different. In this case, it's multiply. Because you have 5 squares. So you technically have 5 times 5, and you have that 4 different times. Okay, so do 2 times 4 if you need to write that out as well. 2 times 4 like so, and you get 5 to the 8th. Okay, those are our 3 basic rules. Off of this, we do other things, such as anything to the power of 0 is equal to 1. Okay, it doesn't matter what it is. It could have been 19 to the 0. It's going to equal 1, no matter anything it is, no matter what. It could be in parentheses, it could be a whole bunch of stuff. Anything to the 0 is going to be equal to 1. The other thing we talk about is negatives. Okay, so this is all review. For a negative exponent, if I have 4 to the negative 5th, in order to solve that, now some people will get used to it and figure it out, but if we were to have to solve this, we need to make it a positive exponent first. So we will switch it from the numerator to the denominator, or the denominator to the numerator, wherever it's at. Some people say flip it. Okay, whatever's easiest for you to remember. Right now, I have it in the numerator, so I put a 1 on the bottom, and I'm going to move this whole thing to the bottom, not just the negative 5. I move the base with it. Okay, if you just move the negative 5, you're going to get something like this, and that's just weird looking. Okay, you just change the whole problem to something completely different. Okay, this whole thing needs to go to the bottom. Some people will do this. This is also wrong. That is you telling me that these two things are the same. That is not true. Okay, if this was a 4 equals 1/4, that's impossible. 4 cannot equal 1/4. Okay, since the whole numerator is going to the bottom, what I have left in the numerator is just a 1. If there's a 1 in the numerator, you need to write the 1. Okay, if you don't, you're wrong. And then we change it to a positive exponent on the bottom, so it's 4 to the positive 5. Okay, the opposite of this is if it were to start in the denominator. So I have something like 1/2 to the negative 3rd. Okay, now I need to move this to the numerator. So it turns into 2 to the positive 3. In this case, I don't need to put over 1. I can if I want to. Okay, most time you'll just see me put 2 to the 3rd. Okay, the reason you don't need the 1 is because it's the denominator. 2 to the 3rd divided by 1 is 2 to the 3rd. Okay, and a last one is, let's pretend we had 2 negatives going on. It's the same thought process. Okay, the 2 to the x to the negative 2nd will move up to the bottom, and the x to the negative 5th will move up to the top. Okay, so it turns into x to the 5th divided by x to the 2nd. Okay, and then it turns into a problem just like our second rule, where we are going to subtract those and get x to the 3rd. Okay, those are all reviewed. This last one was kind of just a little bit extra. We talked about it, but wasn't actually on your test like that. Okay, so with that being said, you could have negatives all over the place. One way, is to move them to make things simpler. Okay, if you need to, pause so you can copy that down. Otherwise, here we go. Okay, these are combination rules. You can see we got 4 examples. These last 2 are actually harder than the ones on your test. If you can do those, you should be perfect for the test. Okay, now how I would approach these is I would deal with any negatives first. Okay, and then from there, one rule at a time. If we look at A, we don't have any negatives. So I'm going to do one rule at a time. First, I will simplify the top and bottom separately if I can. Okay, I don't want to try to simplify the top and the bottom together. Simplify the top, then do the last step. So here we have 2 4s on top, and we got 3 more. Okay, one thing I sometimes ask is how many 4s are on top? Well, there's 2 here and 3 there. We add them together, we have 5, so it's 4 to the 5th. And then I have 4 to the 4th on bottom. Okay, so that was just our first rule of adding exponents when multiplying by the same base. And then now we have our second rule. We're dividing with the same base. So we're going to subtract those exponents and we'll get 4 to the first power. Another way we think about it is how many more 4s are on top? Well, there's 1 more 4 on top, so I leave 1 more on top. If there was 1 more on the bottom, I'd have left it on the bottom. Okay, what I mean by that, you don't need to write this down if you don't want to, but if you had something like this, okay, there's 1 more on the bottom, so leave it on the bottom. So it's 1 over 4 to the positive 1 on the bottom of the fraction in the denominator. Okay, so that's where I have more 4s at. Okay, that's just extra pause if you want to copy it down. Otherwise, I'm going to erase it. Okay, so that was A. For B, I'm going to move the negative up top. Now, some people would like to simplify first, and that's perfectly fine. Whatever you're more comfortable with. You can either simplify the top first, then move the negative, or move the negative first. I prefer to move the negative first just because sometimes you won't be able to do anything until you move the negative. So I'm going to take that, I'm going to move it up top. I'm just going to rewrite everything. Okay, I have x to the third, that whole thing to the second, times, now that x to the negative third becomes a positive 3, so I have x to the positive 3, and then I go about doing the rules. Okay, the first rule is a power to a power, so I'm going to multiply those. So 3 times 2 is 6, so I get x to the 6th times x to the 3rd. And then now this is our first rule, multiplying the same base, add the exponents, and it's going to turn into x to the 9th. And that is our answer. Okay, just one rule at a time. Some people try to skip around. Don't skip around. One rule at a time. Okay, pause if you need to. Otherwise, moving on. So these ones are a little bit more difficult. Okay, one thing to note is get rid of the parentheses whenever you can. Okay, if you don't, sometimes you'll make little mistakes. So I would say always try to get rid of parentheses first, then worry about moving stuff. Okay, but sometimes people try to move stuff and they'll get something different and chaos happens. Okay, so I'm going to rewrite what's left over. It's still there, 2 to the 5th. Okay, so I got my 2 to the 7th on the bottom. And now I have a negative, but it's still a power to a power. So I'm going to multiply the negative 3 times the 2, and I'm going to get 2 to the negative 6th on top. Okay, again, this is more difficult than one of your tests. So if you can do this fine, you're going to be perfect for the test. So then now here, we got rid of the parentheses. Now I'm going to move my negative. Okay, I'm going to move the negative 6 to the bottom. One mistake people tend to make on these is they want to move other things. 2 to the 5th is positive, so it stays. 2 to the 7th is positive, so it also stays. Okay, they're in the same spots. That 2 to the negative 6 is now a 2 to the positive 6 on the bottom. Okay, you can see why this is a little bit longer. And then we got to simplify from here. So on the bottom, I have 7 and I got 6 more, so I have 13. I'm just going to add those together. So I'm going to have 2 to the 5th over 2 to the 13th. Okay, and then this kind of turns into that problem that I made up on the first example. You have more 2's on the bottom. So right away, you know you're going to have more on the bottom. So write it as so. And then use how many more? Well, 13 minus 5 is 8. So I have 8 more on the bottom. So I have 1 over 2 to the 8th. And that is my answer. Okay, you notice we didn't do much. We did one step at a time. We got rid of the negative, or we got rid of the parentheses. We moved the negative, and we just did one step from there. Okay, pause if you need to. Otherwise, we're doing the next one. So as I said in the last example, get rid of the parentheses first. So the top, I'm not going to touch anything yet. I'm just going to rewrite it. So I got x to the negative third times x to the fifth. And then 2 times negative 3, just like over here, we get x to the negative sixth. Okay, and then I'm going to move my negatives. My x to the negative third is going to move to the bottom. My x to the fifth is going to stay up top. And my x to the negative 6 is going to move to the top. Okay, so on top, I still have my x to the fifth. I now have a positive x to the sixth. And on the bottom, I now have a positive x to the third. Okay, again, got rid of the parentheses, move the negatives, one little step at a time. And then now we do our rules. On the top, I'm going to add my exponents. So I'm going to get x to the 11th divided by x to the third. And then my next rule, I need to subtract my exponents. So 11 minus 3 gives me x to the 8th. Again, another way to say is how many more x's are on top? Well, there's 8 more on top. So I have x to the 8th. Okay, and that is it for this. You'll have a practice to follow it. And yeah, see how it goes.